The next topic we're going to look at are rational functions in which we multiply and divide. So we're really only adding a step to what we've already learned in the simplification process. So when we multiply two rationals, the first thing that you want to do is factor everything in the numerator and denominator. So actually, rather than taking and distributing things out and making it a larger polynomial, we want to actually take and break it down into the smaller pieces. That way we can then cancel any like terms in the numerator and the denominator. And then the last step is to combine the remaining terms that haven't been canceled to create the rational expression. So it would look something like this. 4x squared minus 100 over 12x plus 60 times 3x plus 21 over x squared plus 2x minus 30. So remember that with fractions, we are going to multiply numerator with numerator and denominator with denominator. But to help us out, we're going to actually use these smaller pieces when we factor. So for the first one, we can factor out a 4, and we would get x squared minus 25 over, and then 12 x plus 5 times, factor out your GCF of 3, and you're left with x plus 7. And then the trinomial in the denominator, we want something that's going to multiply to give us 35. Then when we add, we get 2, so that would be a positive 7 and a minus 5. Now this x squared minus 25 can factor more. So we can go ahead and break that down. So we want everything to be a linear factor. And then we're going to look at what will cancel top and bottom. Because when we're multiplying, that means that it all gets put together. So we can still write it as two separate, and we can cancel across the multiplication sign. So anywhere that I have the same expression, I'm going to cancel. And then I multiply what's left. So I have a 4 and a 3 in the numerator, divided by 12 in the denominator, which is actually 1. So that whole expression is going to come down to a 1. And then our domain restrictions, again, are going to be from the original. So we're going to go back here and look. So x cannot be equal to positive and negative 5 or negative 7, because those are the three that we would have in the denominator. For this next one, we're going to factor out our GCF, so 3 in that first numerator. And then a plus 4, a minus 4 in the denominator, times, we have a GCF of 10, and then a GCF of 5, which leaves us with 2b plus 3. So again, cancel anything that we have top and bottom. 3 times 10 is 30, and we have an a minus 2 that didn't cancel, and then we have a plus 4, a minus 4, and then we also have a 5 there. So 30 divided by 5 is going to be equal to 6. We have a minus 2 in the denominator, a plus and minus 4. So if we go back to the original, we have one more factor that we canceled out, and actually that needs to be a, because that's the variable there. The other one is b, so b could not be equal to negative 3/2. Okay, so on the domain restriction, a little bit different because we had two variables, but we want to focus on the cancel expression. So again, everything that's left didn't have anything to cancel out with top and bottom. When we divide, we're going to use the same process that we learned for dividing fractions. We keep the first expression. We change it from division to multiplication. So now it's the same thing that we just learned. We flip the second expression, keep, change, flip, and then you follow the rules for multiplication. So we're just going to take and rewrite all of the division using our multiplication rules, or division rules for fractions. So this problem would become 2a squared minus 4a. We can actually go ahead and start to factor here. So let's go ahead and take that GCF. So in the denominator, something that's going to multiply to 10, and then add to 3 would be a negative 5 and a positive 2. So we can go ahead and do this all in one step. I'm going to change that to multiplication. So I kept the first, I changed it to multiply. Now that numerator is going to become the denominator and vice versa. So I'll go ahead and factor out that GCF. So you see that I'm just taking and rewriting and factoring kind of all at one time. If you need to write more steps out, then you can certainly do that. And then now it's multiplication. So we just have to look and see what it is that we can cancel top and bottom. So what factors do they have in common? That's going to be it. So we would have actually an 8a, because we're going to multiply it by that 4 that's still there. And then a minus 2 over 5 times a minus 5 times a minus 4. And you see, we're not going to multiply things back out. We're going to leave that just like that. There's no sense in doing extra work. And then we have to say that a cannot be equal to 5 and 4 and negative 2 because of domain restriction. So again, we want to go back to all of the denominators that we see there in that first problem. All right, I'm going to work this one kind of up here where I have a little bit more room. So the first one, we're going to factor out a GCF of 15. So then we're left with 15 minus, or not 15, it's going to be 1 minus a, because we factored out the 15. The denominator has a GCF of 3, which leaves us with a minus 4. Change it to multiply, and then flip a squared minus 6a plus 8. So that would be a 4 and a 2, and they would both need to be negative when we factor. And then that denominator is a difference of squares. And now we just have to look and see what we have in common. So the only thing that we can factor out there. So 15 divided by 3 is 5. So those will also cancel. But everything else looks like it's going to stay the same. So that would be the simplified expression, but a could not be equal to positive and negative 3. Those are the two that I have left in the denominator, and then the 4 that got canceled out. So it's a lot of factoring, a lot more simplification, a little extra with the domain restriction, but we just added one more thing to what we had already learned how to do in this unit.